Hi pre-calculus students. Today is video 2 of the information that we'll see on the unit circle. Video 1 was the special right triangles. You'll be sending those notes to me. Don't worry, I'll let you know when that is. You'll also be taking these notes and sending them to me. It's on radians and degrees. You already learned this in Algebra 2, but again, it's so important and it's on the unit circle that I think we need to look at this again. What you're welcome to do too is just take a moment and pause the video and get these notes down, and then start that video back up while I'm speaking so that you don't feel rushed. So I'm going to start over here, of course, with number 1. And it is the definition of a radian. So what a radian is another way to measure an angle. You were taught degrees, and degrees are wonderful, but radians are actually very useful in many ways. In fact, just so that you believe me and you pay extra attention, let's look at number 2 real quick. Sorry, number 3. Let's look at the mode on your graphing calculator. Here's the graphing calculator. If you hit your mode button, if you notice, if you go down to the third line, it has radians and degrees, and radians actually comes first on your graphing calculator. We only use radians in calculus, and of course, this is pre-calculus. And radians, why do we use it so much is it actually makes a lot of formulas that are really important much easier to use. So that's why we're looking at radians today. So we already got number 3 done. Let's go back to number 1. So what is a radian? How big is it compared to a degree? The definition of a radian is it's a measure of an angle from the center of a circle whose arc is equal to the radius of the circle. What does this mean? And so let's take a look at what this actually means. So here is the center of a circle, any circle. I made a circle with radius r. I could have made it bigger, I could have made it smaller. And here's what a radian is. So here is the radius, the length of the radius. You can see right here. Notice I just outlined it in red. And what I'm going to do is I'm going to start rotating from this radius upward until the arc that I make is just as big as the radius. Oh, look at that. That's not very, that's a little squiggly. It looks like a kindergartner did that. Anyway, and so this angle right here is called 1 radian. It is the angle from the center of a circle that creates an arc that is exactly equal to the radius. That's why it has like the part of radius in its name. Okay. Notice it is much bigger than a degree. Let's do that again. Let's start where we were, and let's draw another radius on the outside of a circle. Notice it's not perfect. That's okay. Here is our second radian. Let's keep going around the circle. I'm going to rotate an angle that makes another arc as big as the radius. That's our third radian. Let's keep going. Here's our fourth radian. Here's our fifth radian. Here's our 6th radian. Notice it almost completes the circle. It's just a little short. 6 radians. And then we have plus a little left over. There we go. So what happens is how many radians are on a circle? 6 plus a little bit more. All right, so radians again are very big. Okay, so, but I just want to point out that we already knew that. We already knew how many radii, which is plural for radius, was on the circumference of a circle. We drew it and we can see there's 6 plus a little bit more. We already knew that. How did we know that? Let's go over to number 2. We already knew how many radii are on the circumference of a circle because we know one of the formulas for a circumference of a circle is 2 pi times the radius. In other words, the circumference has a radius on it 2 pi times. Now let's look at this 2 times pi. Pi is about 3.14, and 2 times that is about 6.28. Let's go back to our circle. Wouldn't you agree that we have about 6.28 radians on this circle? That's how many times a radius is on the circle, 6.28. So we already knew that. So isn't that really cool though? But I wanted you to really understand what a radian is. Now let's go, I'm gonna switch to a black marker so you can see my writing. Let's go over then to some of the information they asked you for in Algebra 2 and pre-calculus and calculus. So, how do we convert between degrees and radians then? Right? If we're going to be using both of them and later just radians and calculus. Notice I started out at the top here with it circled. Once around a circle, you knew was 360 degrees. And now we're saying that that is equal to 2 pi radians. Well, where did the radius go? Where is it? Well, let's come on back over here. Let's take a look at this radius. Without a doubt, it is 1 unit long. And you can say, well, how do you know that, Miss Culver? Did you measure it? Couldn't this be 1 foot? Couldn't it be 1 meter? Couldn't it be 1 centimeter? No matter what, even if this radius is 3.68 inches, it's 1 unit long. No matter what, it could be 3.6 feet, it is 1 unit long, right? So this radius, let's go back right here, no matter what, is 1 unit long. So a circumference is 2 pi in radians around, and we also know that that is 360 degrees. That's how we know these two are equal. Okay, let's talk about some other degrees that you're going to see on the unit circle because we write those in radians, right? And let's see what they are. Well, if 360 degrees equals 2 pi, if I divide 360 by 2, I must have to divide 2 pi by 2. Oh, that's easy. That's pi. Now that's a pi right there. This is very important. This is kind of what we use for our conversion factor. 180 degrees is equal to 1 pi radians. Let's keep going. 90 degrees is going to be on our unit circle. Notice I divided 180 by 2. So let's do that to pi. Pi divided by 2 is simply pi over 2. So if someone asks you, what is 90 degrees in radians? We'll tell them that's pi over 2. Let's keep going. Let's do 90 divided 90, and let's bring that to 45. So we're going to divide 90 by 2. Let's just keep going. And we are going to divide pi over 2 by 2. That's going to give us pi over 4. So when we do our unit circle, where we see 45 degrees, we're going to write pi over 4 radians. All right, excellent. Well, let's go down to 60 degrees. Well, it's not that easy to get from 45 to 60, but that's okay. Let's go back up. Let's start with our 180 because we know that that's equal to pi. What would I divide 180 by to get 60? By 3. So here we go. I'm just going to divide pi by 3. That is simply pi over 3. Excellent. Well, it's pretty easy for me to get from the 60 to the 30, right? We'll just divide by 2, right? And pi over 3 divided by 2 is equal to pi over 6. So these radian measures that you see here are all the radian measures we are going to be using on the unit circle in our next video, and now you know where they came from. So I just want to check over here though. So we did pretty good switching from degrees to radians. How would we easily switch from radians to degrees? Well, here's what we know. Here's the most important information right here. 180 degrees equals pi. So if I have radians with a pi in it, how do I switch it to degrees? Wherever I see a pi, I put 180. Let's do it. Let's start right here. 180 divided by 2, 90. There we go. 180 divided by 4, 45. 180 divided by 3, 60. 180 divided by 6, 30. Super easy to convert radians back to degrees when you know that the pi is equal to 180. Here's some questions they may ask you in the book, and we deal with a lot in calculus. What is 11 pi over 6 in degrees? What is pi over 3 in degrees? And what is 3 pi over 4 in degrees? So these are all radian measures. How do I turn them into degrees? Well, I could use a little formula and multiply and cross out units and things. But class, I want you to know it's actually super easy. So what are these radian measures in degrees without using a formula or a calculator? We just have to memorize or know a few radians to be able to do this. Let's take a look. I'm going to come on down here. 11 pi over 6. What is this radian measure in degrees without doing any hard work? Let's just take a look at it. What is pi over 6 in degrees? Oh, look at that. It's 30 degrees. I have 11 of them. What's 11 times 30? 330 degrees. Look at that. Just by knowing the smallest part of this radian measure, I didn't actually need to do any real hard math. 5 pi over 3. What is this radian measure in degrees? Let's take a look at the part that we have. We have pi over 3. Pi over 3 is 60 degrees. We have 5 of them. 60 times 5 is 300 degrees. Look at how easy that was to convert. Let's do one more. Pi over 4, right? 45 degrees. We have 3 of those, 3 45s. That'd be 135 degrees. There we go. The math is actually much easier than you would think. And again, thank you. I hope that this cleared up some questions you may have had when you learned radians in Algebra 2, and we will be working with this a lot. Have a good day.